Chapter 4.3, we're going to talk about prime factorization. Prime, there's that word factor, factorization. Okay, a couple of terms we need to define. First one is prime number. What is a prime number? Prime number is a number with only two factors. And those two factors are 1 and the number. 1 and the number. Those are the two factors on any prime number. And some of those prime numbers are 2. 2 is a prime number. 3. What's another one? 5. 7. 9 is not. 11. 13. Yada yada. It goes on. But only one, for example, 2, only 1 and 2 goes into 2. Only 1 and 3 goes into 3. Only 1 and 5 goes into 5. So we have prime numbers, and then we have composite numbers. Kind of like you have vowels, and then you have consonants. Well, we have prime numbers, and we have composite numbers. What's a composite number? It's a number with more than 2 factors. A number with more than 2 factors. Prime only has 2 factors. Composite has more than 2 factors. Okay, so now we're going to do just a few examples of prime factorization. Prime factorization. Same as your title. Okay, now don't write this. I just want to show you something first before we start. Again, don't write this. Probably last year you did a thing called factor trees. That you took a number and you broke it down into factors. That's what we're doing right now. Except I'd like to show you a different method rather than taking up all this space. Let me show you a different method than factor trees. Okay, so let's find let's break 12 down to primes. First, we know that 2 goes into 12. 2 times 6 is 12. Now what I'm going to do is something a little different, and that instead of making a factor tree, I'm going to bring this 2 down, because that's already a prime. And then 6, I can break that down. That's not prime. I need to break it down. Well, that's the same thing as 2 times 3. Okay, so here, this is all primes. So we broke it. So this is the answer. We broke it down to primes. Or you could write this as 2 to the second power times 3. Because there's 2 2's and a 3. 2 squared times 3. And if you multiply this out, again, this equals 12. 2 times 2 is 4, times 3 is 12. And the same thing here. This multiplies out to 12. We're just writing them out. We're breaking them down into prime numbers. Prime factors. So instead of writing all this, we broke it down to this, taking up a lot less space. All right, let's do the number 100. Let's start breaking that down. 100, well, I know 2 goes into that. 2 times 50. All right, well, this is a prime number, so I'm just going to bring that down. 50 can be broken down. Hey, isn't 50 just 2 times 25? All right, so I'm going to bring my prime numbers down. 2 times 2. Now 25, 5 times 5 is 25. And there you go. I just broke this down. These are all primes. 2 and 5, those are primes. So either you could say this is our answer, or we could rewrite that. We could rewrite that. Let's see, how many 2s? I have 2 2s, and I have 2 5s. So really it could be written like that also. All right, here's our last example. And this time we have variables involved. Well, let's see. So I have 6, which is, so we have 6a to the third b squared. Well, 6 is 2 times 3. And a, well, again, these are not numbers, but I need to break them apart. So this would be a times a times a, right? There's 3 of them. And for the b's, b times b. So you see, I broke this all down into factors. And that's it.